Hello everyone, Violin, welcome. Ci video hi torque to angular momentum topic ibol na. Rotational motion chapter ring video thum na hintin ci pen hi rotational motion chapter hi bon hi na video li hi kan compact ding hintin. So ci video pa hi khong sau deu me thi na ji chu topic hala hi torque to angular momentum to moment of inertia angular acceleration ti ho umin ja hi ja na bon jang ke ha hi cover dio. So even if you are preparing self preparation bolong na himay na. So ci video bol pao here. So I'm going to cover everything. Okay. Right. Let's start. Masabi na so torque. Torque hi pidi na ha. Simple ta setting aso na. So it is the measure of the force which is responsible for rotation. Okay, it doesn't say na direct. It tells us how much a force acting on an object that causes object to rotate. Okay. Now, so it is the moment of force ang kita talk by na. Chichu measured of rotational force that is applied on an object. So that force creates rotation. Okay, rotation ang humalachun na. It's a force as a rotation ang humalachun. So here that torque is created. Okay, what we call torque is created here. Formula to be a torque formula to. So torque is equals to R cross F. Na. Si torque pa hi velocity vector. So na. So this is a vector. It has direction. Okay. Direction and direction pa hiti ki holo ham tele chalai bita cross product na cross product direction ki bang chu chalai right hand thumb rule pa ho. So first you take your right hand, follow the first vector, you curl your fingers towards the second vector, your thumb points towards the third the torque here na pa he. So basic vector the direction of cross product bol pa ho na chi wona ga video pen lai. So here see cross product cross product formula you apply vala torque to magnitude of R into magnitude of F into sine theta na ji. So here see torque jong hina R cross R into F perpendicular jong kiti R perpendicular into F jong kiti jo aji jo pham dele chibita. Suppose I have a rod here. Okay, example, this rod is fixed here. Like a fixed so ala he rod chunga hi force hung ekda jo che. So if a force is applied like this at some angle, okay, kutile rod pa ha ki rotate them. Ki rotate de chuna aji chobita hela force pa hi ka split ala chun. So along the side I have one component and along the side I have another component. Force pa hi component niyam cho khat pa hi F cos theta heza khat pa hi F sin theta. Theta na ale chila hi force F sin theta to F cos theta pa hai na which pen hin rotation hi a cos ha. So rotation is due to which of this component. Hechi pa hi force kha choi tai rod kham jona ti tu ni chin kai la chon rod pa hai ke paidem ke paido di chona jala hi ai wang choi ti lan kai wa chon rod pa choi ti lan ke paida da so. Okay, so now the rod is going to rotate like this clockwise due to this force. Okay, so this force is responsible for rotation. So there is a force responsible for rotation na chiji achuk torque create ta cha chejo torque na ji ding wala chun piha. So here you see the next thing you have to observe here is this component F sin theta pa hai na. So it is perpendicular to the length of the rod L. Okay, length pa to ki perpendicular na chila hi tang formula R pen hi piha. So what is R in the formula? So here this is the distance between the axis of rotation, okay, axis of rotation and the point of application of force. Okay, force ki apply na point pa to na axis of rotation ki ka distance pa cho depends R he cho jela in he thim khajo. So axis of rotation and the point of application of force atila chun chila hi figure hi ha. So this point if you see, so this is the point of application of force. Okay, abana che pa hi fix na lai phya this is the axis of rotation aman ki ka distance pa he na he che ben hi R he cho je he. So here R is basically L na L ki pi chola eta he meaning di charan he rungai jo jela he talk to R cross F is a R cross F here to R to pham tele it is the distance between the axis of rotation and the where you apply the force. Okay, that is the R. Abana chalai force pa hi pham tele it is the perpendicular component of force. cross product hong phale khon na cross product pa hi see it is always if you have a cross product of these two so always they become perpendiculars okay this is cross product pa hi na itai ki je thecho r into one of them will be perpendicular okay r into f perpendicular hilole r perpendicular into f so phale angular momentum in phale vela in mandiu jana jela hi see the point is h force pa he relation chito hin h r pa he perpendicular so jela hi na so they should be perpendicular so I can write the torque as jela diagram ko na hi na torque so piham so r perpendicular to l he ja f perpendicular to piham f sin theta so this is the torque okay chi formula ka banala chun na so r to l he ja f perpendicular component of force the force which is perpendicular to r okay chi pen chu piham f sin theta ka apply la chun chi so l into f sin theta this is the torque okay chi ta banga chuna chi r perpendicular jang ge hol thai cho chala hi ga avele chun see if I draw a triangle here okay so here this is r na then what is this so this angle is also theta okay that means triangle pa side he vela chun he chi r pa he chi r jala na r jong vector cho he chi r component ni jo chilang component kha to he chala jong component khan jo okay triangular loi man wala na see here in this right triangle I have relation adjacent side pa he ha so this is l cos theta okay one perpendicular side pa ho l sin theta okay kasi banga cha force to r pa hi perpendicular hi ngai ja chuna he ji force to hi force f pa kala he ji l sin theta pa kala jong hin torque ka ji thejo chula hi aji jo pyam tele he ji force pa to hin l sin theta pa hi perpendicular chuna je pen hi okay so here another way of writing is the torque will be equals to force into l sin theta he ji l sin theta beham perpendicular component of r okay that means l sin theta so the r which is perpendicular to f na ju l f into sin theta ake bang ma hang pot ki je torque so there are two ways of writing okay so here so what is f perpendicular it is the component of force so which is perpendicular to r okay ahilole r jong so biham the component of r which is perpendicular to force okay ju torque na okay let's practice writing how to use torque example kha galaute chila hi road khanum cho road pa hi chila ki fix na la khalang en la khalang ki fix cho chila ki fix in tin so it can rotate about this axis okay so now if I apply a force of f so at some angle say 37 na 37 I can apply cho it's like road pa length hi l okay atila torque chu za diham so what will be the torque so here you have f perpendicular okay so which is what f sin 37 okay sin 37 should be 3/5 na so here this is 3f by 5 okay abana khat chu f parallel chu changam na iban chi pen hi ki manglo chu iman lo na f parallel pa chu so we want only the perpendicular component of force okay abana r chu pi de hala hi he chalai fixed point na he chi axis of rotation chu chalai fixed point here abana force ki apply na chu chalai point of application atile aman ki ka distance pa he na he chi pen r ki di chu so here r is given as l okay atile torque chu pi ham torque chu r into f perpendicular r chu pi ham l f perpendicular chu so 3f by 5 okay so the torque is 3 into lf divided by 5 okay that's just a torque na chu so one more example I have a road again uniform road na road ho uniform cho diagram ma uniform da kilo lo wang hina so here this is fixed point okay atile fixed point ga khelo ta to hen let's do a little bit different I have a road so now fixed point is here okay kichun ta cho so at a distance of is at ha so let's say l by 3 okay now force is again applied f so at an angle 37 okay atile to he torque is at data so here again f perpendicular to pm so hi chuna f perpendicular so f sin 37 chu 3f by 5 cho na chala hi ala to hi chi bola ka wol ham tela r hi pi ta to hi to chu okay fix na point la hi okay fix na pa hi chi axis of rotation chuna chila hi ale force ki apply na chu la ha chila hi chona so point of application of force okay so the distance between these two so this is your r okay hi chi za di ha total length chu l la hi hi chi ka chu l by 3 hi le chun l minus l by 3 to r is also like here na subject bol level. So therefore I will have here 2l divided by 3. That depends on r. Okay, so what is the torque here? So torque is equals to r into f perpendicular. Na r to piham 2l by 3 into f perpendicular to 3f by 5. So 3 gets cancelled out. Torque to piham 2lf divided by 5. Exam hon question na l value f value jong ki pi thei na chalai cho a he wangai hon to hi concept i learn cho je a boldan a method pa he na. Okay, so one more example. Let's do two more example na. Suppose I have a rod, so it is fixed exactly in the middle. Okay, that means this is l by 2. Okay, and this is again l by 2. Atila to hi force hi chilonga ki apply da cho force f ki apply a to so lang khalanga force f ki apply na chila hi. Okay, atile question chu net torque. What is the net torque? Okay, to hin value chun force achung lang force pa ho value chun hi chi force pa hi already perpendicular chula na, so then we don't have to take any component. Okay, so let's say the tang he chunga force pa hi value chun hi chi force pa in chilanga kaya la chun it is trying to rotate the rod in clockwise direction. Okay, so let's say there is a torque 1 na due to the upper force but anulang force pa hi value chun anulang force pa hi value nga chil chun it is also trying to rotate the rod clockwise, so this is torque 2. Okay, clockwise torque direction pa na tin right hand level lang torque direction pa tin car le chun so thamina kona pa chuna chu direction of torque so ji to hi bitang t1 pa hi torque 1 tau 1 pa hi right hand thumb rule apply leng he clockwise up pai leng ka tham pa hi into the page chi su chuna chi lu chuna, so that means the direction of the torque 1 is into the page. Okay, so here I have to write cross means into the page, dot means outward. Okay, cross means inward. Similarly, torque 2 zong value chun right hand thumb rule apply lo chun, so if I try to rotate it clockwise, okay, my thumb will be going into the page chi ja chong hi into inwards na atile torque in direction ki bang da cho. Okay, so torque 1 pa zong inward has a torque 2 pa zong inward khutile direction ki ba chun I can just add them. Okay, so therefore what is the net torque? So net torque will be given by torque 1 plus torque 2. Okay, directly torque 1 ko zat deham, so torque 1 is equals to, so r ko piha l by 2 na he ki fixed point of rotation is a he pa hi fixed point of application na, so therefore this is l by 2 is r. So therefore how much is this into f, so lf by 2. Okay, that is the torque t1 abana torque tau 2 khuzat ne ha, again here also r2 l by 2 na 4 zong f mama hikit tun chite ni gom lesion pi de ha, so lf by 2 plus lf by 2, so how much is this? So l into f, so this is your net torque. Okay, right, direction pa he na paten he chin lesion, so ani nia so into the page he la ka adding khat pa so into the page he khat pa so awat ahang pota lesion ka subject dita cho assign pa so na inward na la inward direction so plus na la wala chun outward direction so minus na la ngai na, so it is not a fix. Okay, apolang pa outward so plus na la wala so inward so minus na la de na so na ho tu da cho. Okay, suppose I have a rod. Okay, so now it is fixed at chalai la ki fixed so alai chat hello na ji, so let's say here at l by 3 ki fixed tiute kutil achung langa khu 2f ki kaya anui langa hi z langa f ki kai cho. Okay, so then the question is, will the rod rotate clockwise or anti-clockwise? Hui langa hi de. So here see achung lang pa r hi value chun chi cho na chi za ha si 2l by 3 na chalai hi ale to so chung lang force pa ho value chun it is trying to rotate the rod clockwise. Okay, so tau 1 anui lang pa hi value chun it is trying to rotate the rod anti-clockwise tau 2. Okay, atile tau 1 pa ho right hand thumb rule apply leng inward chuna ji he abana tau tu pa hi second torque pa hi right hand thumb rule apply leng kathamin outward appoint ita cho. So here the second torque is outward. Outward na direction ki bang talo so chala hi. So you find out the individual torque. Torque 1 to pm. So 2L by 3 into 2F. Okay. So choose that 4LF divided by 3. Okay. First torque na. Abana torque 2 zong hi sa diha torque 2 hi L by 3 into F. So this is LF divided by 3. Okay. Torque 2 pa hi outward hi sa torque 1 pa hu into the page. Okay. Atila net torque to piham. So net torque will be given by to inward plus kala so kihin. Inward direction so plus kala la chon outward pa hi minus kala ngai cho chala hi. So the net torque will be tau 1 plus minus tau 2. Okay. As you second torque pa outward chala na si. So therefore I will have here what 4LF divided by 3 minus LF divided by 3. So how much is this? So 3LF divided by 3. So 3 gets cancelled out. So finally I have L into F. Abana the final value pa hi positive so na jela hi minus pi chala. So if the final value is positive, it means that the net is going into the page. As you hon ipi ezo mo ha inward so positive I ezo mo chala na. Final answer so positive ang po do ala chun. So that means the net is going inwards. Okay, the net torque is inwards, right? Okay, that much. Now we'll solve some questions. Okay, the first problem, let F be the force and position vector R and torque is given. Chilai do piha. So R to torque to piha force relation na ji. See in general, okay, in general, if I have a fixed point, from the fixed point to where the force is applied, so I have R, okay. So from here I have the force. Okay, like this na. You can take also like this. Okay, perpendicular force. To ahibtang R to hin F evaluation plane khalam chala na. They lie on the same plane. Okay, so let's say they lie on the XY plane na. So if they lie on the XY plane, okay, I'll write like this: X and Y. XY plane na R to F yum so ale chila he torque hold doling na. Torque to hilangam de ha. So here if I try to find torque, so torque is R cross F. Okay, right hand thumb rule mangleng. So if I follow R with my right hand, okay, I will follow R, so my palm will be facing towards F. Okay, I will curl my fingers towards F. Okay, otherwise it in must have been so first vector so piha R pa hi first vector so right hand thumb rule so na. See, you have to use this right hand thumb rule in every cross product formula. Class 12 magnetism hozong khu right hand thumb rule ki mangso. Cross product of the formula ho na. See, here R is what? R is the first vector. Okay, first vector. So F is the second vector. So a step to piha masapena chu. So take your right hand, follow the first vector. Okay. So first vector pa ka follow dingtin. Bala chu your palm, let your palm face the second vector. Okay. So second vector pa ka face halachun ka palm pa na face halachun. So my thumb will be pointing towards the torque. Okay, or his face zong I like curl towards the second vector. Okay, if I go R and curl towards F, then my thumb will be pointing inwards. Okay, so the torque direction will either be inwards or outwards. Okay, torque pasuna it will be either into the page or it will be outward. So that means first thing, so the torque is perpendicular to R. Okay, and torque will be perpendicular to F. As to R to F to same plane naam chula. Okay, R to F to XY plane naam malasun chila he torque pa he Z axis naam tine chula he. Okay, right? So let's answer the question. Masapena chu piha. So see here direct answer says ingate torque to R to perpendicular here lachun a dot product to 0 rejo. Dot product ko cos hong chula na cos 90 chu piha 0. So here you'll have R dot torque will be 0 and F dot torque will also be 0. Okay, as usual perpendicular here is na, right? So your answer is option A. Okay, next to hi R cross F formula pasin mandi ta chula hi idi ki manam masapena se pkpm force kipi na chula hi force kipi din about the origin position vector kipi na. So that means what is the position vector R kipi din. So here F is given. Okay, So formula chu biham torque is equals to R cross F. Okay. Hita he direct cross product na boldi holo chu chulai determinant ni mandiu na determinant ki mandan jong hi basic maths a vector para ka bol chai ta cho chi. So how do you use that one? So I okay minus j plus k. Okay. First vector pan is masat pendiu chulai he. So this is the first vector. Okay, so this is the second vector. As you second vector is masat version -1. It is wrong. Okay. So first vector so piham r na r a coefficient ho jita 1 1 1 na 1 I cap 1 j cap 1 k cap. Abana second vector so force a coefficient ho jita so 2 I cap 1 j cap 2 j cap 2 k cap na. Abana chela ko na iti ki holta. So first you write I cap. So when you take I cap, so this and this will not participate. You start from the top left, so cross multiply na. Just piha 1 into 1 1 1 2 na minus j abana piha so medial pa pangloading so 1 1 2 2 okay plus k piha kia hu 1 1 2 1 okay hejin hetim no wala basic maths ana chi dio na khon ka video so now you do cross product I so 2 1 is 2 minus 1 1 is 1 so 2 minus 1 okay minus j so 1 2 are 2 minus 2 1 is 2 plus k. It's like 1 1 is 1 minus 2 1 is 2. So if you solve this, is that no pot diha? So I minus 2 is 0 na. So minus k. Okay. So what is the answer? I minus k. Okay, khat to bol me na sila hai. P ke p am sila force ke p na chi force is a position vector r jong ke p ke na sila hai. So tele torque formula cha p ham torque is equals to r cross f. Okay. So how do you do that one? Use determinant again. So I minus j k. Na. Atile first vector pa na zi masat pendiu r na zi masat pendiu din cho. R ko pi ha. So 2 I cap, 2 j cap, 1 k cap na. Abana force pa ko pi ham 5 I cap, 3 j cap minus 7 k cap. Okay. So if I apply the same way, so I into so 2 into minus 7 to minus 14 minus 3 1 is 3. Okay, minus j, so 2 into 7 minus 14, minus 5 1 is 5. Okay, plus k, is that 2 3 are 6 minus 5 2 are 10. So how much is this? Minus 17 I cap. So minus plus 19 j cap. Okay, minus 4 k cap. So is that na So minus 17 plus 19 minus 4 option C. Okay. Formula ke mandan pa na cross product ke boldan pa. Okay, so one more ji medical exam question. Force ke pia force to 3 I cap ke pi na chila hi position vector r chu pi ham 2 k cap ke pi cho ale torque chu pi ham torque chu r cross f. F cross r na ji wala minus 1 mo dio. Okay, so be careful. So r chu pi ham r chu 2 k cap cross f ko pi ham 3 j cap. So if I solve this thing to 3 r 6 na balan chila pia k cross j hung po cho chila determinant ki banglo chu chila ta basic maths ka hil ho chu pita so I okay j bana chu k na ji he so I cross j ka tiala chun plus k cap okay j cross k ka tiala chun plus I cap na k cross I ka tiala chun plus j cap okay but if I go the reverse j cross I ka tiala chun minus k cap. Okay. I cross k ka tiala chun minus j cap. Similarly, k cross j means minus I cap. So k cross j means minus I cap. So here I will have minus I. So this is what? Minus 6 I Newton meter. Okay. Right? So option 2 biham minus 6 I. Okay, bana. So now you have what we call angular momentum. Angular momentum hi pikise na. So see angular momentum of a particle about a point is defined as L equals to R cross P. Okay, R to P ham torque R ki bang chat cho. Axis of rotation apara so the point where the particle is particle na if the angular momentum to P ha. Suppose a particle is moving around in a circle. Okay. Right? So it is rotating about this axis na. Particle umna para axis of rotation pa na hesi r ki di chu. Okay. Right? So r cross p p chu pi ham momentum na linear momentum. To chu he chi pen hi ta you can also rewrite like this. So angular momentum equals to r cross momentum so piha mass into velocity na jihe. So here what is this? Mass pa khoda do mass into r cross v. Okay, this is angular momentum na. Kasi bang cross product ho malachun. So you can write this as L is equals to m into r into v perpendicular, or I can write L equals to m into r perpendicular into v. Now component of velocity perpendicular to r hilole component of r perpendicular to v. Chiten jo multiply ka bola na mass ka multiply chun angular momentum hong pode cho. Azo atto ki bolta bang wa chuna jela he. Okay, so there is one thing you can remember. So m r into v perpendicular na. Aban level circular motion hong perform khala chuna. If the motion is circular motion, then I can write omega is equals to v by r. Okay, in case of circular motion, so angular momentum will be mr into v to piha omega into r na jihe. So I will have here m omega into r square. Okay, question kan ga solve na angular momentum he thim na dinga cho. So here see, suppose I have x and y. X axis to y axis na jela he. So x axis I mi pa kharom jela he observer kharom na. So let's say O. Okay, so what is this? This is the person who is observing the motion of another person P tiu na jela he. It's mi pa P pa he. So it is going towards the y axis speed to jala de. So 2 meter per second tiu de. Person P pa na. So let's say currently it's P pa he 0,4 ma. So O pa he 3,0 am na position cho. So if I want to find out r, see this is r. Okay. So with respect to O, I can write two components of velocity. Okay, one component will be along this side, so which is perpendicular to r. Another one component will be along this side. Okay. But momentum formula sa piha m into r into v perpendicular ito sila na sila he. So component of velocity perpendicular to r jo ko hol ngai jo sila he. Okay. Ale angle he ppd ha. See, what was our triangle? So sila he thoma hiya he 4 hi chun chi 5 na. Angle jo ppta. So this is 53. So this is 37. Okay. Atile sila hi Hichi angle pi 37 hi chun hichi angle pa jong hi 37 hi ngai na opposite angle. So that means perpendicular component velocity pi tin ji ta. So this is 2 into sine 37. Okay, component kala la chun na. So here how much is this? 2 into sine 37 so 3 by 5. So this is 6 by 5 meter per second. Okay, so this is v perpendicular na pa here. So let's say the mass of this person is say 30 kg, 40 kg tivte. Chi pa he na. Atil angular momentum si piham formula apply la chun. So L is equals to mass into so 40 into r so piha jela he. So triangle here is 5 na ji. So this is r. Okay, so your r is okay. Okay, so r is 5. Nah. So m into r into v perpendicular to 6 by 5. Okay, 5 cancel out. Is that a 6 4 24 240? You need to change it in the mass to kg na. R who meter, bana velocity who meter per second. So I will have a meter square per second na. But then unit zidan here unit he choma kan hil ji lo ne so you can derive your own unit. Okay. Achaina ke phal khon units and dimension chapter zo bel ai poldio o chelai khon. So here this is kg na unit zidan cho he chipa he meter hiza chipa he meter per second gom khom leo chun. So you'll get kg meter square per second. Okay. So unit of angular momentum na. Okay. Next part see circular motion equation to mani ke mangho chana. If you remember, then his kinetic linear motion ho bia equation ho. So in linear motion, so the our equations were x is equals to ut plus half at square manu chana jela he. Abana chu khachu bia v equals to u plus at hiza khachu v square equals to u square plus twice ax chuna equation to mo cho. His linear motion hiza angular motion hongi phal chun jipen na mandio. Okay, so in angular motion ti chu pi ha rotation a na rotation a chu hi choi na man dik ne cho so angular displacement na initial angular velocity okay final angular velocity angular acceleration right okay then next let's try to use this equation he equation hoy na this is rotation as ki dong jab so he previous question hoy velocity see they are actually asking from here okay first thing so you're given acceleration alpha kp na question se pm at t equals to 0 the ball has angular velocity omega chuzat kpm 10 kp chuzala hai na angular position theta chuzat kpm so 4 kp na chala hai so the question is what is the most appropriate expression for angular position of the ball so this is a pure maths question okay pure indefinite integral ki mangcha ki bol na chala hai so see you're given alpha okay so alpha is given as 6t square minus 2t angular velocity omega to alpha relationship pita so alpha is equals to d omega by dt chuna jala here so you transferred dt on that side alpha into dt and then you integrate here okay if I integrate both sides I will have omega equals to integral alpha into dt okay so now you put alpha value and integrate it so I will have omega equals to integral so 6t square minus 2t into dt H integral bolation so 6 into t cube by 3 so minus 2 into t square by 2 plus c hung ki habdi chujala constant kha ki habdi chuna indefinite integral ako so here this is omega okay so if you cancel I have 2 here so 2 is gone so omega is equals to 2t cube minus t square plus c he chila ya c hold on nga hai na constant pa hold on nga hai he chi value hoi ki pi chu choi okay so you put t equals to 0 at t equals to 0 omega was 10 okay so therefore omega was 10 at t equals to 0 is that hang pot dia chila hai plus c so c value will come out to be 10 okay so therefore what is omega so therefore omega is equals to so 2t cube minus t square plus 10 chipa hi angular velocity mo ta so question chen pi do ham question chen angular displacement do so position do na chila he so angular position ki dong so chi so athile omega to theta relation chu pita so we know that omega is equals to d theta by dt okay chila ya I bol ta bang ba he na bol ki leu chun so what will you get so I will get here so theta is equals to integral omega into dt hung por ki chu chila he okay so now you put this omega function here and then you integrate one more time khabe to bol belation za dia so 2t cube minus t square plus 10 into dt okay atila chi integrate bolation 2 into t power 4 by 4 okay minus t cube by 3 plus 10t plus another constant c okay c ma man laki na jala he atila chun he chi theta da cho chila ki pi cho bya t equals to 0 a cho theta cho bya 4 ki pi cho na je so you put it again so 4 is equals to h bya chila 2 na so 0 square 0 power 4 by 2 plus minus 0 cube by 3 plus 10 into 0 plus c chila ko na ping po da c value hung po da chila so therefore c is what again 4 okay so finally so what is the angular position so I will have here t power 4 by 2 minus t cube by 3 so plus 10t plus 4 okay which is the answer so option B okay so this is a pure indefinite integral question okay all right next problem so the angular speed is given so angular speed should be omega na omega of a moving flywheel with uniform angular acceleration alpha kp na kp lo so changes from okay so here you're given initial angular velocity and then what is this so final angular velocity so times ang kp na jala times ang kp tin so find out the angular alpha ki dong cho hotela equation which depends on man dio ha so here you're going to apply that one omega final equals to omega initial plus alpha into t acceleration hi hold na chala he hotela matang chala he unit evolution omega unit hoya revolution per minute ki ti cho jala he so what is the meaning of revolution per minute revolution per minute apala hai na radian per second agi convert ji chu so pi kiti hoy na so these are radian okay revolution per minute ang kipi alazon so try to convert that into radian per second idi convert de ha so one revolution aku radian is ki cover 360 chura na angle khu so one revolution means 2 pi okay so 1 minute as a second zaramam 60 second cho okay so therefore if you want to convert revolution per minute into radian per second so multiply by 2 pi by 60 okay so that means one revolution per minute is equals to so 2 pi by 60 radian per second chi conversion unit na so this is your conversion unit okay heji ga bang cha leo chun omega initial khuzat ha so 1200 into so 2 pi by 60 so 2 are 12 20 na ji so this is 40 pi so now you have radian per second okay abana omega final khopi ham omega final jong khu so 3120 into so 2 pi by 60 0 cancel out so 6 5 are 30 6 2 are 12 na so 2 2 are 4 2 5 are 10 so 104 pi radian per second so omega initial omega final time jong formula kon direct put leo chun na zan pot ni ha so omega final is 104 pi is equals to so 40 pi plus alpha into 16th so 40 could transfer leo chun I will have here 64 pi so this is equals to 16 into alpha okay so 16 into 4 is 64 so therefore alpha is at ham 4 pi okay so option zat na ham option B okay next the angular acceleration of a body moving along the circumference of a circle chila he biha angular acceleration direction ki dong cho chi so chila in head you have to note okay note cho biha so here you have torque kiti ho na angular velocity kiti ho ahilole angular acceleration na ahilole angular displacement hicho si hi bona hai na they are collectively what we call axial vectors chicho pitena axial vector kiti cho pitena direction chu it will always be along the axis of rotation okay torque direction jong hina torque direction jong hi axis along the axis of rotation heading angular velocity jong angular acceleration jong hina along the axis of rotation hindi cho sipen jo melsi jing lo so they are called axial vectors so along the axis of rotation okay next angular momentum to moment of inertia relation na so L to I relation chu ta so angular momentum chu ti jita so L is equals to m into omega into r square ki jita na chala hi so here if I take r square and m together and then omega mr square chu pita moment of inertia chu na mr square chu so here L is equals to I into omega okay new formula na angular momentum in terms of moment of inertia chu I into omega ta ki jita hi chu tai okay so let's solve questions on that uniform rod okay rod kharke pia so mass to 300 grams so length to 50 centimeter okay ml but uniform angular speed of pia chepeni omega na omega to 2 radian per second ke pia so about an axis perpendicular to the rod at the end dicho hitia he rod hongumale so axis perpendicular to the rod at the end na chepeni so about this point moment of inertia chepita chala hi so mass m length l hi ala chun chila hi ml square divided by 3 chuna chala hi so calculate the angular momentum of the rod tang I chu ki he I chu pha value pula chun jan pot dia chala hi so 300 gram for 0.3 kg na so length for 50 centimeter to 50 into 10 power minus 2 whole square ml square divided by 3 okay chichu zat ha khul chun so 3 0.12 1 by 10 jong ji thena chala he okay so 5 5 are 25 2500 into 10 power minus 4 so divided by 10 ka ji so chala ya 0.1 pa he na 0.1 pa nu yang so ding so 10 ka ji chala he so here 0 gets cancel out so now I have I okay ale angular momentum chupita so I into omega so here I to 250 into 10 power minus 4 into omega hoi pem 2 na ji. So here how much is this? So 2 5 part 10 to the 4 5 10 power minus 4. So this is 0.05 okay, so kg meter square per second jula na from unit pacho. Okay, so 0.05. Next to hi torque to angular momentum to moment of inertia na relation value daso. Basta bena torque to angular momentum to relation ju piha. So here derivation hoy macha to pilaw na jela he torque to so dl by dt ta theki thei jela he. So I can write torque, so external torque is equals to, or net torque is equals to, so dl by dt jela l he piha chi angular momentum jo seven hina l pa he. So from here so d by dt into angular momentum formula so pita I into omega so na jela he. So here what is this? So if I take I outside, I have d omega by dt. So here this is what I into alpha. Aso phala chi formula in man na chi. So to an he jo so here torque can be written as dl by dt. Okay, ale tu he net torque pa he na chi pa he 0 hong itale pitire. So if torque is equals to 0, so I will have here dl by dt equals to 0. Okay, chuchupite na ha. So that means L is constant, right? Constant kada ki differentiate ala 0 chula chala hi. Okay, so if L is constant, that means it is not changing. Okay, so if the net torque is 0, then the angular momentum remains constant. Okay, constant till initial to final value zon ki bang na ki hello dit na. So that means chuchupite na. So principle of conservation of angular momentum. But collision boleva conservation of linear momentum bol na so net force 0 hi lechun linear momentum ki conserve is so net torque 0 hi lechun angular momentum pas ki conserve hi, right? So here if angular momentum is conserved, you have I initial omega initial equals to I final omega final. Okay, question khali ga solve the line. So first question, a wheel of moment of inertia 0.5. So this is given, so radius zonkepia. So it is rotating, okay, about the axis at angular speed of 20. So here you are given omega initial, okay. So I is given, radius is also given, okay. It picks up stationary particles of mass 200 grams at its edge. Okay, find the new angular speed of the wheel. To jite hem jo wheel khari tayom na. He wheel he ke pai jo moment of inertia. So if it is rotating like this, it is about the center of mass na. Chila moment of inertia jo pkpm chu 0.5 kp jo jala he. Ale omega jong kp na omega initial chu ham omega initial chu so 20 radian per second. Okay. Atile to hi ebitiam tele ke pai pai hi it picks up the stationary particles. To so particle dang khare na. To so aning chara hina hong ki bi dan ta so hong ki bi ala chun he che particle pa mass cho piha 200 grams cho pen he chu 0.2 kg na che to chu pa he chai ran koi fa la chun he chi particle pa jong ki rotate cho a ki rotate ala chun moment of inertia anai na jong so here see this is how much 20 centimeter. So particle pa heavy chun so if I have a mass m, so rotating about this axis at some distance, okay, like this, atila moment of inertia mr square chola na jala he. To he chi anyo pa he na, so particle pa moment of inertia he chobing ga hol la chun is that yeah, so mr square. Mass chu 200 grams chu 0.2, radius who is at 20 centimeter na so 20 into 10 power minus 2 the whole square. mr square so this is what 0.222 by 10, okay, so 400 into 10 power minus 4, so 0 cancel out is that 80 into 10 power minus 4, okay, chipen chu moment of inertia neo pa ko na I tu tiute. So for the small particles atile a chaina jovata hechi hong ki bi ala na, so ki bi zo achu hechi speed pa thama hong ki khel ta beta. Okay, so let's say finally when it sticks here, so the new angular velocity pa cho omega final tiuten new moment of inertia pa cho na to chong ki bi ala chun resultant moment of inertia chu so this plus moment of inertia of this, okay, chu final moment of inertia na to chu conservation ga bola chun tang chila hi external torque ma cham no chu chila hi, Okay, amama ke paya na abana particles of pick up hisa. So here you can conserve moment of angular momentum. Okay, so L initial equals to L final. So I initial omega initial equals to I want I want you here. So here I have so I1 into omega initial should be equals to at sa so ani nihon am khom na I1 plus I2 into omega final. Kipay khom ni ta chon ni na. So put the values. So 0.5 into is that 20. So this is equals to 0. Is that so this is a 0.008. Okay. So sum of them will be so 0.5 plus 0.008 into omega final. So 0.5 into 2 so 5 2 are 10. So I have 10 divided by so 0.508. Okay. So this will be omega final. So I will have here 10 1 2 3 divided by 508. This is omega final. Okay. If you solve you'll get here 19 point something. Okay. So 19.7 I think. So radian per second. Okay, next a diver is having moment of inertia is I initial. So 6 kPa, so through axis of center of mass. Diver khun he chuna mi tui pi sunga diving ball ho. So they can kipai the chuna ma center ata sa khu ta rotating na about ata sa kipai ti na so he was rotating with omega, so omega initial is 2 radian per second. Okay. If he folds his hand, if he folds his hand, so there is a decrease in moment of inertia to I final I final to 5 kg meter square na. I initial to biha. So I initial to 6 kg meter per second meter square, but I final to 5 kg meter square. So what will be the new angular speed? Okay, so conservation of angular momentum. So L final equals to L initial. I initial omega initial equals to I final omega final. Na chila here. So I initial to 6, omega initial to 2. Na so I final to 5 into omega final to hold on here. So how much is the omega final? So 6 2 are 12 divided by 5. So 5 2 are 10, 5 4 are 20. So 2.4 radian per second. Depend here new angular speed of the diver. Nah. Okay. So angular momentum conservation here team na question is solved. So here I think we have 2 more questions. So a wheel the moment of inertia wheel ang di pala na hang pia ring hisi here. So moment of inertia is given as 0.1. Rotating about the shaft at so angular speed to so 160 revolution per minute. So 160 rpm here. So a second wheel is set into rotation of 300 rpm. Okay. Second wheel dang paisa hong kilantin to original first power wheel chung na tayo. So initially you have the wheel, okay. Wheel masabasa tayo page na. So now the initial wheel was rotating with how much 160 rpm page na jala to wheel dang khat mama chu ipiha izar ke paiha che pa hi 300 rpm ke pai na che pa hi to 300 rpm ke pai pa hi hitainan la dio achung sa ainan koi dio. Okay, you keep above it. Atila chun na koi wa chu vela chun speed ten ki banglo pu chula na chi ai banga chunga hun koi velang na nga le chun chong kha phala chun they are going to start rotating with the same angular speed. Okay, ani ni hona chuna. So here question should be when they finally rotate with a common angular speed of 200. To chunan koi wa chu. So here the new one will be like this. So thinga je na. Ani ni ke peida zo he. Ani ni hona he. So 200 rpm ke peida na to he. So find the final moment of inertia of the second wheel. First wheel pa moment of inertia cho pi chipa he 0.1 ki he na. Second wheel pa he ki hello cho I2. So we don't know. Alenan koi khom zo wa hi moment of inertia cho pi I1 plus I2 ta zo he. I1 plus I2. na chu biham 0.1 plus I2. Okay, so final moment of inertia na. To so momentum conserve legend ibiha so L initial equals to L final. Initial as chum ke pai hon chula na je. So I1 omega 1 plus I2 omega 2 should be equals to. Finally, we keep them together. Kutila I net I final into omega final. Hita hang macam okay. So put the values. Atila so 0.1 into masapa khoizar ke payam 160. Na plus ani napa so I2 ki hello na so izara ke payam 300 ke pay na. So this would be equals to izar ha I final ho 0.1 plus I2. Okay. So into 200. So a non-variable I2 boss here na si pen solve legend. So open the bracket and you solve this one. So what will you get? So here I will have space of 9. So 16 plus so 300 I2 should be equals to is that 0.1 into 200 so 20 okay plus 200 I2. So here 200 I2 pa ko velang transfer velang 16 pa hezi lang transfer leochun. So I will have here 100 I2 should be equals to so 4. Okay, 20 minus 16 so 4 na sila he. Atil I2 so zanang pot diham so 0.04 kg meter squared. Okay, second wheel pump moment of inertia so na je. All right, one more question. A thin circular disc keep is so mass m, radius r is rotating. So about its own axis, passing through the center, perpendicular. Moment of inertia so mr square by 2 pajo. So with angular velocity omega, so this khanum jo chahe. So this pahi about its own axis. Okay, it is rotating. So I to biham mr square by 2. Na Japan here okay. So here if another disc of same dimension till radius ki bang din okay. If a mass ki bang na mass m by 2 is placed gently on the first disc. Kutila to so this dang khan mamam kit na sila he. Iban chapa mass hi m by 2. Okay. So now hi chapa hi I1 tutin atha pa hi I2 tilo hai na I2 hi zat ha mr square by 2 mama chola na this mama hi za so ai bang m2 m by 2 ngiding r chu ki bang na r square by 2 which is at the chala here. So mr square divided by 4. Okay, to 2 or 4 na. So the moment of inertia niyam ta atila chu first pa heza ke pa omega ke pa cho second pa he pya. So if another disc of m2 is gently placed on the first kotile masa pa ke pa lo so omega is 0. Okay. Agyap to pa na ti pa ke pa lo indin ta achung lagi koi me na chala he. Atila nan koi khom zo wa zo final acha pi ha. So this niyam da na final acho. So first this, second this, and they will rotate with the same common angular speed. Okay. I final to biham I1 plus I2. Moment of inertia direct plus bolachun. So mr squared by 2 plus mr square by 4. Okay, so this is how much? So 3 mr square divided by 4. Okay, final moment of inertia so na. Isi bolai holam tele angular momentum conserve na ding aso na. So L initial equals to L final. Initial chu piha initial chu changsa ke pai na khat pa he. So I into omega. So I1 into omega initial. Chu piha omega ke pijing na omega initial so. So this is equals to omega final into so the final angular speed. So how much is this? So mr squared by 2 into omega should be equals to a new moment of inertia to 3 mr squared divided by 4 times of omega final. Okay, so mr square gets cancelled out. So 2 are 4. Until the final omega to piham. So 2 omega divided by 3. Okay, is that ham option D. Okay. Abana last concept video dengan na. So torque equals to I into alpha zo ka derive penchu. So here see this derivation. Chilaya ko na he na. So I will have this torque equals to I into alpha. Okay. Question solve na ki bang ji jo Japan here. So this is important. Sila hi piam tile ta angular acceleration, angular torque to angular aso ka siba so hi teni hi axial vector chula na si. So they are going to be measured about the axis of rotation. Okay. Remember angular acceleration, torque ani na chu with respect to the axis of rotation dita chu. Okay. So they are always direction is always along the axis of rotation. Na axial vector ho chu. Okay. So no theory macam lo na formula hina mel chiu like sizing. Okay. Okay, let's solve one example here. Suppose road khalam chana chala hi. So a road is let's say fixed here at one end. Okay, fix alison hi taki rotate hi dine cho. Okay. So let's say it is released. Road pa hi horizontally aki koi chu ta hi. Na. So it is placed horizontally and if I release it, it is going to fall down. Okay, like this. Kutile road pa hi ka release alison ki pa hi ta hi. So it will rotate like this. Okay, clockwise na. If you want to rotate ham tile weight and nature na road chu. So here what is this? This is a rod of mass m, length l. Okay. So therefore it has its weight at the middle. Center of mass chu mg na weight. Alechun to hin release leo chun hita ke pe chu ibola ke pe ham tila torque omji azu na. Hije torque chu koina produce ham tila chun a weight in a produce chu. Okay. So there is a force acting perpendicular to r na. Torque I bolta chala r chu piha r chu. So the axis of rotation apana point of application of force and distance pa chu ji r h o ji. So here r is at halai hi. So here what is r? R is l by 2 na chala hi. This is center of mass chu mg ek ahi ek ngai sa na chala hi. So therefore see question chu piha what is the angular acceleration? Okay, that is the question. So here if I use the formula torque equals to I into alpha. So torque chu piha chala hi. So r into f perpendicular na r chu l by 2 into f perpendicular to mg. Okay. So this is equals to moment of inertia about the axis of rotation. Chala hi zat ha chala hi. ml square divided by 3. Na road aning endpoint akong. So here if you put this value, so m into l square divided by 3 into alpha. Okay, you solve for alpha. So gets cancelled out. L khat to l khat cancel ding. Kutil alpha chu zat hang ponam. So 3z divided by 2l. Okay. Question acho value l value z value hong ki pi asun da put wal jing ki sizing. Okay, answer hong po jing ni na la hi. Right? Tang chila hi he theni ding wa road command man jing zana road ki hilo ring ho jong ke mang thai this ho jong ke mang thai chu chila hi. So for example you take a disc. Suppose you have a disc. So disc of mass m radius r na chila hi ki fixed so chila hi. So if I release this, it can rotate. Okay, chala center of mass chala hi na. So mg chu nui langa ko kutila chun. So it is going to rotate clockwise. Okay, if I release this one na atile chala r is at ha. So here this is r na. Axis of rotation apana point of application of force sanchu. So this is basically the radius of the disc. Okay. Atile ehon moment of inertia chu chala is at ha. Oh, then theorem ni simo chala na lahi. So you can use parallel theorem or okay like that. So here I will use parallel theorem. So about this achu jata moment of inertia chu mr square divided by 2 na chala hi. Hotel about this achu h point achu jat ha. So mr square by 2 plus md square. So d chu piham r na mr square. So this is basically 3 by 2 mr square. So here moment of inertia chu about the axis of rotation na about chala hi. Kutile torque equals to I alpha ma apply leuchun. So torque chu piha. So R into F. F chu piham mg. Okay. So this would be equals to I. So 3 by 2 into mr square into alpha. Okay, what is alpha? Solve leuchun. R gets cancelled out. Gets cancelled out. So alpha is equals to 2z by 3r. Okay, so angular acceleration pa chu na chila hi. Okay, so next question. A solid cylinder mass chu 2 kg na chi mass ke pia radius chu 4 cm. So it is rotating about its own axis at the rate of 3 rpm. He chi omega ke pi chi omega chu so 3 revolution per minute na chi. Atile revolution per minute chu pia so 3 into so 2 pi by 60 radian per second na si convert ngai cho So you'll have 10 pi by 10 radian per second. Okay, so this is omega. Question the torque requires to stop. Okay, stop after so this much revolution. That's like 2 pi revolution kiti hai na. 2 pi kiti so number kiti na so like angle cover hilau so so here so this 2 pi is number. Okay, so that means in 2 pi revolution how much angle is covered? So theta equals to 2 pi into 2 pi. Just like confuse it. But suppose let's say in 2 revolution na. So in 2 revolution the angle covered is 2 into 2 pi. Na chi revolution zat chula. Chila question na PKPM tela in 2 pi revolution kiti cho chila he. Just number of revolution tina cho 2 pi cho angle hilaw na. So that means in 2 pi revolution angle covered is 2 pi into 2 pi. Zat he cho 4 pi square. This is theta. Okay. About the next thing too, it requires to stop at the so that means omega final will be 0. Okay, right? So you have to find out alpha. Okay, chilai talk kitong chilai na. A talk kito just talk to piha talk to I into alpha chila formula cho na chi alpha hold of chun I chu solid cylinder I chu ki he chula na solid cylinder ki chu this to ki bang chula mr square by 2 jana jala. So here if you apply the formula omega final square is equals to omega initial square plus 2 into alpha into theta. The formula pai mangla chun. So aking as na final omega to 0 da cho. So omega final is 0. So initial to that ham initial to pi by 10. So pi square divided by 100 plus 2 into alpha to hold on na. So theta to be ham 4 pi squared. Okay. So from here you transferred. So minus pi square by 100. So this is equals to, for 2 or 8, alpha into pi square. So pi square gets cancelled out. Alpha who is at bottom. So minus 1 by 800 radian per second. Chila minus retardation tinebo so Japan here. So this just means retardation. So therefore you have a negative acceleration. Okay. Until alpha omta I chu piha. So what is the moment of inertia of the solid cylinder about its own axis? Chuchu mr square divided by 2. Mass who's at 2. Radius 4 centimeter na. So that means 16 into 10 power minus 4. Okay, in meter square. So divided by 2. So this gets cancelled out. I have 16 into 10 power minus 4. Okay, kg meter square. Moment of inertia so na. Therefore torque is what? Torque is I into alpha. I who is at 16 into 10 power minus 4. Alpha who is at so 1 by 800. So don't care about the sign, okay? Kasi about sign he retardation na. So here you solve this one. So A1 is 8, A2 are 16. So 2 into 10 power minus 6 Newton meter. Okay, so this is your torque. Option B. Okay. Next, again, a constant torque. Torque kipi na chi. Torque kipi ya. So will the moment of inertia jang kipi so chi I. Okay. So about an axis passing through its center. So starting from rest at omega initial to 0. Na angular velocity to omega final kedong so after 3 seconds. So t is equals to 3. Kutile angular velocity after 3 seconds whole num valachun. So you can use this formula initial plus alpha into t. Na Japan ki bang thai chula. Ai wa ki vat cho piha alpha bo ki vat chula na alpha cho hila panang podo de ham. So torque equals to I into alpha. So torque to moment of inertia kipi na value put lechun. So torque to 100. Moment of inertia to 300 into alpha. So what is alpha? Alpha is 1 by 3 radian per second. Okay. So alpha to put lechun. So omega final is equals to omega initial to 0 na plus alpha to 1 by 3 into time to 3. So 3 gets cancelled out. I have 1 radian per second. Okay, alpha to radian per second square. Okay. Okay, so it's option number 1. Okay. So last second question. So energy kipi jo chala hai. Okay. So energy is spent in increasing the speed from 60 rpm apara. So 360 rpm chan su kalna ding na energy change in energy work done ki bol pa chu 484 kipi jo Japan. So that means delta ke. So initial tang atila chu 60 ke pai jana chilai energy khat cho so initial energy na to chu chilai ko na hi 360 ki kal sa de tine cho okay so this is e final so a kalzat chu piha so final minus initial na kalzat pa chu change pa chu okay right so what is the question find the moment of inertia I hol ngai na chilai so he question pa hi energy ki apply ja hi na energy formula ki apply na hi ja kan koi cho chala hi tang rotation kinetic energy formula che pita so ke is equals to so half into I into omega squared okay until initial chu see this is initial omega initial chu piha so 60 rpm chu so 2 pi by 60 radian per second okay so 60 gets cancelled out so 2 pi radian per second chu omega initial na omega final chu zat ham so 360 into so 2 pi by 60 okay so 6 are 36 so this is a 12 pi radian per second chu omega final na chapa hi omega final atile initial kinetic energy ka sebanga chi chi ke pi pa he na chi so chi final minus initial so atile final to initial pa jo chom chom hold leng na so final chu zat ha so half into I into watang same wheel bia chala wheel ma chala na wheel chu ki khelo chula speed box chu ki khelo chu initial moment of inertia to final moment of inertia chu ki bang ne chu wheel pa chu ki bang ma hi ja chu na so omega initial square so final initial kinetic energy chu pam half into I into khat pa hi final so omega initial the whole squared okay hotela change pa chu pi ha so delta k equals to k final minus k initial na chu pi ham so half I into omega final square minus half I into omega initial the whole squared chu pi ha so half to I chu command so I will have here omega square minus omega initial square value put lesion half into I into final chu pi ha 12 pi na 12 square root of 144 pi square minus 2 square root of 4 pi square abana change pa chu pi ham 484 ki pi chula na question ako so here you solve for I 2 pa chu chilang chi ding so I will have here 484 into 2 so divided by 144 minus 4 ko pi ha 140 pi square okay pi square chu pi ham so pi chu 22 by 7 na pi square 22 by 7 so this is I okay so you solve this one 22 into 22 so 484 okay gets cancelled out so 7 2 are 14 okay and then I have 2 1 is 2 2 10 are 20 so I will have here I is equals to 7 by 10 is equals to I so therefore I is what 0.7 okay option B nah. Okay so last question so which of the following are correct expression to achu the h video formula in sim si chuna to je lai question ang ki dong da khat question khana ma sa pen jo torque formula che pita so torque formula chu R cross F chuna che pen here so that means from the option the last option is correct the first option is wrong okay torque formula to ju ya chuna ale b na pa khopi ha so torque is equals to so d by dt into R cross P ki ti chuna che he atile P pa khu ga phu leuchen so R cross mass into velocity okay like this atile chila hi R chu kala loading so cross mass into so dv by dt okay dv by dt chu pi ha acceleration chula na che he so R cross m into acceleration m into a chu pi ha force chula na che he so this is force okay so therefore what is this R cross F so that means this is correct na okay so B part is correct D na pa C na pa helale C na pa he torque equals to R cross so D by dt into P okay so P chu pi ha R cross so D by dt into mass into velocity to mass khol do leuchen so you're going to get this thing again okay so that means C is also correct na ale D na pa hu diam so torque equals to I into alpha jong di chula na so this is a result so therefore B C D E Okay, hi chan hi chi video dinga talk to angular momentum. Okay, topic ai bol ho na. So hung sao zeb zong le topic zo si a bon chang ke na chilai ka cover cho. So you have just go through all of this. So remember, okay, every formula we have done na. Formula bol zo si a bon an mel si diwa. Okay, so I hope you understand. I will stop here. To cho video khat ki vat na lai na chi chapter ading a hi. So pure rolling equilibrium problems ibolong na. Okay, so thank you for watching. I'll see you in the next part. Okay.